So exceptions, what do you mean by exceptions? Exceptions, we use it in the programming in order to control the flow of our program. So exceptions indicate that something is wrong happening at runtime. So we need to catch this uh, runtime error. So exceptions will give you the benefits or the ability to deal with the problems that in a controlled manner at runtime. You can control the error. You can you know from where this error comes and how to handle it. So it can be a simple or complex program design. We will see by examples all these terms. So we have three terms that we will use a lot in exceptions. We have the keyword exception. So it's object in object-oriented, it's object. The exception, you can extend that. It's a class. So this object will will what will generate, it's the signal that will be generated at runtime if there is an error occurred. So this exception class will generate the errors, will give a signal. Error signals here will be generated by exception class. So throw is the signal that you will send from the location that you captured the error. So you'll send the signal through using the throw keyword. So this is the second keyword that will be used with exception. So to send a signal, you will use the throw keyword. The last one is the catch. So it's the location that the signal will be sent to. You will send the signal through, and here is the handler that will receive the signal. Okay, it will interrupt or receive the signal. All right, so throw keyword is the keyword that will be used to send signal of the error. When the error occurs, you use the throw to send the error to the handler or the capture. Try keyword. So try keyword, it is the keyword that will be used followed by a block. After the try, you will put your code in the block, and if there is an error, you will send through the keyword through to the catch block. We have another block that will handle the error. So this block will handle the error or will display the error. So it's the handler. So this will handle the error. You will understand by examples here, all three keywords, but you have to be aware that we are talking about throw, try, catch. All right, so uh, a function that throws an exception, a function that generates the signal of error is called from within try block. So try block will generate the signal and the catch block will receive the signal. So if a function throws an exception, a function terminates and try block is immediately exists, you'll stop the execution of the program and you'll move to the catch block. So if catch block is found that matches the exception, so there is some kind of matching between the throw and catch block, so it will be executed if found. If not found, your program will terminate it immediately and you will not see what the error comes from your program. So we have example here about the throw statement. You see here, this is just a function here that will return an integer, and this is the name of the function, total days. So this function will do what? Will receive the number of days. So we are expecting the number of days in a week's should be this number. The number of days must be from 1 to 7. We have only 7 days within a week. All right. So this function will calculate if you give 2 weeks. So how many days in 2 weeks? We are expecting we have 14 days. But here we are sending the number of days. So we are sending from 1 to 7. All right. So this will do the calculation of how many weeks and how many days in the current week. For instance, now if you have we have 7 weeks, this for anyhow, we have a condition here about the days. The days must be greater than, so we have a condition about the days. The days must be greater than 0. At the same time, the days must be less than 7. If the days, for instance, -1 or 8, so you will check here. If this condition is violated, then you have to use the keyword throw. There is an error, and you will send a signal. So it's very similar. If you use cout here, you can use cout, just use cout invalid error, you'll stop the execution. But using throw, we can do it using throw. We just send a signal here. But this signal be sent to where? This is our signal that we will send using throw. So we have error. Then we will send to the catch block. So you see here, we will send to the catch block. So this is the catch block here. The catch block will receive the message or signal as a pointer because we send it here as a string. So we will receive as a string here. So it's character. We will print out the error. So you see in the main here, what we have in the main, we have an integer total days, the days and weeks. We just ask the user to enter the number of days. We are reading the days and weeks. So we are using the try to check if to validate the input. So we will call this function here, and we are passing two values that we have received from cn. All right. So we are calling this function and we are sending the days. If there is error, we will stop the execution here. This line will not be displayed. If there is error, you will move to where? You will move to the catch block here. You will see the error. If it's fine here, there is no error, you will continue and execute this line. Then you will move here. You will not execute the catch block. So catch block only will be executed if we have a throw signal. If there is throw signal, we will execute the catch block. Otherwise, we will skip the catch block. So you will see here, we will try this code here. So you discard here, then we have this example here. So you see, this is the function that will check the days, and here in the main, we are reading from my user, we are reading the number of days and the weeks. We have a condition on the days only. So here we are calling the function here. We'll see this one first. Then if there is an error, we will call which one? We will call, we are throwing the error here, so we will call this one here because we are sending this message. You see here we have two catches, but later we'll see which one will be called. But now we will try to call this one, error 1. We will call it here error 1, and this one we will call it error 2. All right, so now execution. We have to execute this code. You see now we key in two values. The first one is the days, so I will make it 0. Then how many weeks? We have 3 weeks. So we will enter here. So you see the total of days, sorry, we have the condition here to check if the days less than 0. So we will try with the negative number here. So sorry, we have error from here comes if the weeks are 0, So we are calling this catch block. We are sending the error s. So s is what here? S is a string as a pointer. It's not a constant string. We'll see the difference later. So now we will try to execute this one. We will make the weeks here. So we are giving -1 or 8 for the days, and for the weeks 3. So we will execute. So you see we have error 1, invalid number of days. All right. So if we have the weeks are 0, we will re-execute here and we will make the number of days 3, but the number of weeks 0. So we will have error 2. So we have error 2 here generated by throwing this signal. So you see, this is the same function. You have catch here, we have catch here, but the type of the string that you are receiving here is different. Here we are receiving a constant string. So you see, it's like this, but this string is different here. So it's different representation of the string. So if this one is 0, you will call this one. If there is something error here, you will call which one? You will call this one. If this one is not there, if this one is not exist, so what you will see here, I'll try to make C out here just to show you. This is C out here. Uh, this is the end. I just to check if the program reached the end line or not. So this is the end line here. All right. So now we don't have catch for this kind of error. I'm throwing the error, but here I cannot catch the error because this is different format. So you'll see here, if we have error, so now we are executing the program. I'm giving 8 days and 3 weeks, so I'm executing here. So terminate called after throwing instance. So you see, you cannot capture the error. All right, so the program will be terminated because you don't have the catch. You will not see what kind of error you have here. You will not see this statement. So this is the benefit of the catch. If you have the catch block, you will see the statement. So you see here, this line wasn't executed. But if the program is working correctly here, so you'll see the end line. If you have here 3 days and 5 weeks, now you will see the end line. So you see we have the end line. Okay, guys, any question about the try catch, the basic concept of the try catch throw signal, how to differentiate between different catches here based on the type of the signal? Do you have any question right now?
Doctor,
Mm-hmm.
do we have to make message pointer inside catch in the parameter of catch?
Which one catch, this one or this one?
Each one, they both have a message as a pointer.
Yeah, it should be like this is the correct syntax. You have to follow this syntax. You will receive as a pointer, not the message like this one. This is
Hmm.
not, this is the correct syntax, but you have to differentiate between the coming string. Is it defined like this syntax or this syntax? Because we have two different receiver. This is the receiver of this kind of strings, and this is this is constant string, we call it. All right.
Okay, in line 10, in the first row. For what?
In line 10,
Line 10.
okay, this is the first
Yes.
row,
We
will
should not.
be,
We should
this
not
is
make.
the receiver, yeah, here, constant.
We should not make appearances. Should be only like this one.
Should be in this format, yeah. No need for parentheses. Just send as a constant string.
No. Okay.
All right, so we see here now more details about this syntax. So see here, This is the correct syntax. You have to be aware about the syntax. You have to use the constant here. Otherwise, you are expecting to receive a different signal. All right, so we have try block and exception. So we'll move to the program here. You see here, we have different type of strings. The first one, we call it a literal string. The second one is C string. So you see here, this is the literal string here. And the second one is C string. So you see, we define and initialize directly. The last one is the C++ string. So we have class string. So we have different receiver now in the catch. So this is C string and this is C string also. This is C plus. So you see here, this is the receiver of the first type. And this one is the receiver for the second type. And this one is the receiver for the third type. So you have to be aware about the catcher. Catcher must receive the appropriate string. Okay, guys, clear right now. We are throwing the exception here, and here we are receiving the exception. And you have to be aware about the syntax here. Okay, all right. So I assume it's clear for you right now. We have try catch. So you see here, we have try. You must have tried, of course. The throw must be included within a try. In the previous example, here, you see this function is already included here. So the function here is already inside a try. You must have the try block before. So this function is automatically included here inside the block here. Otherwise, if you don't have the try, you cannot throw the signal. So try must be exist. All right. So this is the basic syntax. You must have try, then you have throw, then you have to define the appropriate type. After that, you will get the catch block. So the catch block comes after the try. Okay, so uh, we have the example here. So here we have without constant here. So we have to do the correction, assuming that we don't have exception, but we are throwing which kind of signal we are throwing here. We are throwing a string, a C string. So we are expecting here to receive this syntax. So this syntax must be match the exception. So I'll check if we have this example, but this is the key idea. You must correct the code with a constant in order to receive the appropriate string here. Okay, guys, so we have the example here. We have 12, 2. If it is correct, so we have a condition on the denominator in order to make the division valid. So if we are dividing by 0 here, so you will get this signal, cannot divide by 0. So you see this error. So end of program here. I will check if we have this example here, divide by 0. So divide by 0 here, division by 0, this is positive. Divide by 0, we don't have this example, but this is the key idea here. Okay, so in case you enter 0, you are dividing by 0, you will throw the exception here. You have to be aware about the constant here, so you have to add constant here. Okay, guys, so we have the try, then we are calling the function. If we have error, we will go to the catch. This line will not be executed if you have error, so this line will be skipped here. If you have error, also this line will not be displayed, the end of the program. So you'll go to the catch, you will display, and you will terminate the program here. So after the catch block is finished, the program will resume. Sorry, you will continue, of course. You will display the error and continue here. You see here, if we have error, in our previous example here, we have the error, so we will continue here, see out to the end here. We will just display see out. We make it end line here. We add, so this is error. We have this is end of program. So end of program here. All right. So we see when we have error, this line will be printed. So we have 8 and 3 here. So you see end of program here. You have after the error, you display the error and you continue. So you will display this line here. Okay, so in this slide here, you see the flow of the program. If you have an error after the error displayed, you will continue here. So the program will not be terminated. If you don't have the catch here, the program will be stopped. So if we don't have the catch here, you will not see the last line as I explained previously. I will repeat here just this note. If you don't have the catch at all, you don't have the catch block. So what you will see, sorry, we don't have the catch here. We will try to execute. So what kind of error we have here? All right, so we need the catch, of course, but if you don't have the appropriate catch, now we will change this one to be different catch. All right, we'll use only one catch here. So we will try to re-execute now. We have 8 days. We have 8 days and we have 3 weeks now. We don't have the catch. So you see here, you have different error will be raised because you throw here. If you don't have the appropriate catcher, so you will see a signal comes from the system. So the program will generate for you terminated code after throwing. So this is the default string that will be received by the built-in catcher. All right.
Excuse me, doctor.
Yeah.
So if there was no, it won't function in case that it tried it and it threw an error, but it didn't catch it. But what if there was no error? Will it run normally?
Yeah, of course. There is no error. This statement will not be executed. If there is
Okay.
no error, it will flow normally.
Okay.
So
Thank you.
without errors, 3, so it's fine. So you'll see the total number of days and end of program. There is no error signal. If there's something wrong, but the catcher is wrong here because we don't have constant here. So this is not the appropriate catcher. So what you see error comes from the system. So if you have constant now you will see error 1. I'll retry here. Sorry, this is need here. I'll re-execute here. So now we have error. and we have the appropriate catcher. So you see error 1. All right, because we have the right function that will receive the throw, because we send the signal. Now we will check if we have the appropriate catcher, otherwise the system will generate the error. Okay guys, clear at this point. You must match the catcher with the throw. All right, otherwise you will flow normally here. If there is no error, you will flow normally. So exception not catch, as I mentioned, that an exception will not be catch if it is throw from outside the try block. There is no catch block. We already explained there is no catch block matches the data type. But now, if the block is outside the try block, for instance here, if this function is outside, if I move this one outside the try, so I move it before the try, so it's outside the try. So now we will try when the function is outside. So we have 8 days, which is wrong. We have 6 weeks. Then we will try. So you see, there is an error, but we cannot call this function. I'm looking for this function here, catcher, but because this one is outside the try, so you cannot send the throw to this one. So it must be inside the try. So this is the condition here. We have two conditions. The first one, you must be inside the try. The second one, you match the type. Otherwise, you cannot capture the error. If an exception is not caught, the program will terminate here. So the system will give you the error and the program will stop the execution. So an exception class, we have the built-in, because this exception is already defined as a class. So you can extend it, you can change it, and you can capture different signals from the system. So you'll see here, now as a class, the exception as a class, you'll see by example, then you will understand what's going on here. So you see here, now I'm throwing what? I'm throwing a class. This is class negative. So you see, it's not string. I'm throwing a class. Where is this class negative? If you come back here, you will see this is the class. Class negative and empty. It is empty class. Just to define class, we call it negative size. You can name it up to you. All right. So I make it inside the public section. So I call it class negative. So here inside the throw, I call this class throw. I'm throwing and sending this class. So now in the implementation of this class here, you see here now, inside the catch, I'm receiving not a string, I'm receiving a negative class. Where is this negative class? It's inside the rectangle. So you see here, this negative class inside the rectangle. So in the catch, I'm changing where? I'm changing in the throw. So you have to change in the throw first. You are sending a class, and in the catch, you are receiving a class. In the catch here, you are receiving a class. You see, I'm receiving a class, not string. So this is the implementation of the class. I will just print out the error. This is my error. So you see, there is no implementation for this class here. No implementation. It's empty, no functions inside. But I'm using the class as exception. So this is a key idea. Exceptions as object. So an exception class can be defined in a class and throw as exception by a member function. So an exception class may have no members. Members pass error to the catcher. The class can have more than one exception class. So you see here again in this example, what I'm doing, I'm defining a class, empty class inside. I call it negative size. You can call it whatever. You can make any name is acceptable. Then inside the throw, you have to use it here. You have to use it as a function. So you are using the class name as a function here. So where I need to check these negative values. So you see here inside the set width, I want to check this function inside the class. If the width is positive, it's fine. Otherwise, I have to throw the exception. All right. So, of course, you can use the previous syntax, but this is another way to throw the exception. You can use this syntax here. You can just throw exception like this in here. You can throw string, but here we are throwing a class. And here we are receiving a class. In the catcher, we are receiving a class. All right? Is it clear, this idea? Of course, you must do it inside the try. So you see, I'm checking these two functions, set width, inside the try. So you see here, set width and set the length must be inside the try. You have this function and this function inside the try block. The try block followed by the catch block. Okay, guys, clear this idea how to use exception as a class. So you see the execution of this program. If you have a negative width, so you will get this error. You will get this line. If you have an error, then you will end. So you'll continue the execution of the program. You see here, after we display the error, we will continue here. Okay, clear this example, how to use the class instead of the string. You send a class and you receive a class in the catch block.
Yes, doctor.
Mm-hmm,
In line 28 in catch,
mm-hmm.
uh, we made their parameter rectangle and negative size. Why did we use the scope resolution operator?
Because this negative size is a class. Negative size is a class. If we look back at the implementation here, the prototype, so it's a class, right? So negative size is a class. This class is where inside a rectangle. So you have to use the scope of the class in order to access this class as a function. You access this class. We have class inside class. So we are using the class resolution here. We have to use this one because this one is belong to this one. It's very similar to the functions. Okay.
Okay.
All right. So what else we have? We have the built-in exceptions now. So we will illustrate this idea with the example here. So you see here now inside the catch, I'm receiving what? I'm receiving exception object, object E of type exception. So previously we don't use this rectangle. We are receiving string, we are receiving class, and here we are receiving a built-in class. So it's built-in class. We call it exception. All right. We are receiving the address of this object. So where is the throw signal now? The throw signal comes here. Sorry. we have the try in this block. So now we don't have throw. So we will check the memory. So the throw comes from here. If you have an error, we cannot allocate the memory. So this is built-in exception. I will allocate the memory, but if there is no memory, no enough memory, I will throw exception. So it's automatically here. You are throwing the exception of what? Of not enough memory. So this is this one. This is bad allocation, you call it. So you are throwing this type of exception. All right. So what you see here, if you don't have enough memory, so the error will be raised, and here you can view what kind of error you have. Its system error will be generated by the system. If we don't have enough memory, we will throw the error, and here we'll see what kind of error, because here we have a list of errors, system errors. We have runtime error, we have failure in the system, we have memory allocation error. So here we are using memory allocation error. So now if we execute this code, what's expecting to see? Let me explain this code first and why we have error here. So first in the main, you see here, I have a pointer p, so I have a counter, and I have integer size, but you see this is very I'm allocating very large memory for this pointer. So this will consume one memory. So this is power. We are calculating the power. So it's very lengthy. Clear why this integer is very lengthy? Because you will calculate the power 2 to the power 20. So this will give you very long number. You will store it in the size. So now the size will consume around 1 megabyte memory. Okay, because you have a very long number here. We'll store it in the size, so we are consuming a lot of memory. Already we are consuming a lot of memory. So then you will go in this while loop, infinite while loop. You will try to allocate a memory. Every time you will try to allocate a memory here. We have a counter. So we are allocating a memory. Each time B will allocate a memory. We don't have the delete. We have only new. Each time you allocate a memory, you allocate a memory of this size. So you see, it's very big number until you don't have any enough memory. At the beginning, there is no error. You see here, at the beginning, you don't have error, but at the end, you don't have enough memory. So you will raise the error. The system will generate the error. So what kind of error? This is bad allocation. So if you come here, you see, to know what kind of error, because exception is a class, and inside the class we have many kind of errors. This is the list here. We have bad casting, we have bad exception. So here we have bad memory allocation. So if you see the output here, this kind of error. So you see, this is the error. When you print out here, with what function? So this is what function will be used to print out the type. So you see, this is the type of bad allocation of memory. So it comes from here. It's standard bad memory allocation. Okay, I will try to check if we have this program here. Bad memory allocation. We have memory allocation. We have this example here, division. Okay, guys, by the way, you will get this output. At the beginning, you can allocate memory, but at the end, you don't have enough memory. So you will get this kind of standard error. Okay. Any question about this built-in errors that you can raise? All right. If it's clear, I have to move to the last topic of exceptions. So as I have mentioned, exception is a class. So if you open this class, you can see that you have different type of functions. What we have used here, we have used the what function, and we make it virtually in order to extend this function. So it's a class, this built-in class. Inside this class, we have different type of functions. We have two functions, virtually meaning that you can override these type of functions. We have used what in the previous example here. So e dot what, you are calling the function what. So this what function will generate the appropriate error. Okay. So now in case you will extend this class, you have to make your own exception class. What you have to do, you have to extend this class. So exception class, I'm designing my exception. I call it divide by zero. So I'm extending this class. So I'm changing the what function. So if you see the previously, what will generate for you, this is the output of what statement, bad allocation of memory. So now I will change the output of this function here. I will make it division by zero. All right. So you see now I'm overriding. I'm using the same syntax. If you check for the syntax here, the prototype, so constant character what row. So I'm using the same syntax here. So this is the function that I want to override here. So I'm using the same prototype except of virtual. You don't use the virtual keyword here. You just use the same prototype, and you implement here. You will print out, you return back the error. So here we have a function divide. So we have a class divide by zero, which is a class here. So we have the exception here. So if we have something error, we will throw a class E. So inside the catcher, we have the catch here. We are receiving exception class. But now we are receiving our extended, because this is different type. We are sending E of type divide by zero. It's not the standard one. So now we are receiving the error. So we will print out what, but now we will get different output. We will get this output here, division by zero, because we are overriding what function. All right, so we will check if there is error. We will call something bad here, then we will print out the exception. So this is the last example. We'll try to execute and explain again. We have the class here. Okay, I'll check here. We don't have class. I'll check if we have here the examples. Abstract class. Class. We don't have the implementation. I'll try to implement. Okay. Divide by zero. We have Okay, I think it's not implemented here. I'll check this one. This is string. We don't have the implementation here. I will re-explain again for you what we have here. We have a new class. We extend, we make inheritance with this derived class from the exception. The exception is built-in class exists in the system. So we are changing the function what. So this is the what function here, which is already exists in this class. So this is a class already exists in the function. I think we have the source code here. I'll try to take the source code of this exception here. All right. Okay. We have the class my exception. Okay, I'll try to copy this example here. So we have a new file here. Okay, so you see here, I have my exception class. I'm overriding the function throw. So inside the main, I have try. I immediately throw the exception. I assume that I have an exception. So I have an object here of type my exception. So this is my exception. Okay, I will throw it, and here I will receive the exception, and I will display what kind of error. So this is my exception here. So you see here when I execute this one, right, it is untitled. All right. So you see now you just throw the exception and display in the catch here. So my exception happened. My exception happened. Clear this example how to extend the public class function and change the output. Otherwise, if you don't have this implementation here, if you just throw exception, if you have just exception here, my exception here, so I'm throwing the exception class. So what you will see here, you will see, so you see the standard exception here, because here you have a lot of kind of exceptions, so you will have the standard one. So if you look back, so you have, this is standard, this is the root exception. Okay, guys, clear that we have a class exception. You can extend it, you can throw it immediately here. You just make an object and throw and see what kind of error. Any question before I end today's session?
No.
All right, this is the end of the exceptions. Next class, we will start with the templates from here. Function templates. I'll check if you have examples here. I already explained this. You can throw your error, and here function templates. Next class, we will start with function templates, which will be the last topic in this course. All right, I'll stop my recording here.